Okay, here we go. Chapter 2, review for the midterm. I'm not going to go over all the questions, just the ones that are here. Any of the book problems that are listed, you can find the answers in the book. And if you want to see them done, come to me in class. But you can find the solutions. So these are really to go over the problems that you can't find the solutions for. For some of these problems, like here, double root and triple root. So when you're finding the zeros, make sure if it's x minus 2, you say that's a double root. So x equals 2, and it's a double root. But work on your synthetic division, polynomial long division. Plenty of great questions that we've gone over in class you can check out. Here, we need to look at these quadratics. We want to find the vertex, the x-intercepts, the y-intercept. Space is tight on this, so I say do it on another sheet. For me, I'm going to actually just sort of do this above. So here, A is going to be above, B will be in this space. This is quadratic. You need to recognize that this is vertex form. So if we want to find the vertex for here, it's going to be hk. So we get a -4, comma -1. Done, right? hk. Opposite of that, same number as that. The x-intercept is going to be where y is 0. However, with this one, please note, save yourself the time, the vertex is below the x-axis. Here, this negative means it opens down, so that means that there is no x-intercept. It does not cross the x-axis. For the y-intercept, we need to make x 0. So for the y-intercept, we're going to do y is equal to -0 plus 4 squared minus 1. So we're going to get y is equal to -16 minus 1. So y is equal to -17, but that does us no good. We have to write this as a point, 0, comma, -17. And then, of course, we already said this opens down because it has that negative coefficient. I don't know, put boxes around these. X-intercept opens down, and the y-intercept. I can actually put that there. Right. So that was nice, simple, straightforward. The next one is where we have the standard form. Sorry, don't know why I blanked on that for a second. Vertex, we need to find the x-coordinate first, so that's -b over 2a. That's also the axis of symmetry. So b is -12, so -b is +12. 2 times 3, so we get 12 over 6. So x is equal to 2. Knowing that x is equal to 2, we plug that back into here. So we get 3 times 2 squared minus 12 times 2 plus 11. 3 times 2 is, 2 squared is 4. 3 times 4 is 12 minus 24 plus 11. This is going to give me 23 minus 24. That gives me that the vertex is at 2. That gives me -1. The x-intercepts are where y is 0. So 0 is equal to 3x squared minus 12x plus 11. So you have to factor. Of course, if you have a problem factoring this, you will, because you can't factor. You need to use the quadratic formula, b squared minus 4ac over 2a. Start plugging stuff in. So x is equal to -12, which is +12, plus or minus the square root of b squared, which is 144, minus 4 times 3 times 11 over 2 times a, which is 6. If I simplify this, I get 12 plus or minus 12 square root of 12 over 6. Simplify this again, 12 plus or minus 2 root 3 over 6, which simplifies to 6 plus or minus root 3 over 3. What we can do for the x-intercept is we can actually write that as 2 different points. So we're going to do 6 plus root 3 over 3, comma 0, and 6 minus root 3, comma 3 over, or comma 0. So that's the x-intercept. The y-intercept is where x is going to be 0, but for standard form, it's also just this number off to the side, the constant, if you will. So the y-intercept is 0, comma 11. There we go, 0, comma 11. And the direction of the opening, because we have a positive coefficient, it is going to open up. And those are my answers. The vertex in a box too. So do know how to work both quadratic in vertex form and standard form. Here we want to write the equations of these. Should be fairly straightforward. Again, we're going to be using both methods here, or both forms. We have a vertex, so why don't we use vertex form? A times x minus h squared plus k. So the y is going to be negative 2. Oh, sorry. So the vertex is 3, 8. Sorry, 3, negative 8. So h is going to be 3. K is going to be negative 8. We can use this point 0, negative 2 as y and x to find a. So if we plug all this stuff in, we'll see the only thing left is going to be a, which is what we need to solve. So we get negative 2 equals 9a minus 8. We add 8 to both sides. So we get 6 is equal to 9a, or a is equal to 6 over 9, which is 2 over 3. So we put that back in, we get y is equal to 2/3 x minus 3 squared minus 8. And that is it. Number 1. It doesn't say to write in standard form, so might as well just leave it like that. If it did say standard form, obviously multiply this out, but that's just some basic algebra that you absolutely can do. All right, for the second one, B, we are going to have these zeros. So if we have those zeros, that means that the factors are going to be minus 4 and x plus 5. I do need an a in there. I need a leading coefficient. So what I'm going to do is I'm going to use this 0.7, negative 2 to figure out that leading coefficient. So I can plug it in as it is now. So negative 2 is equal to a times 7 minus 4, which is 3, times 7 plus 5, which is 12. So that gives me negative 2 is equal to 36a. So a is equal to negative 1 over 18. So plugging that in, I'm going to get y is equal to negative 1 over 18 times x minus 4, x plus 5, or x squared plus x minus 20. Distribute this in, so I get y is equal to negative 1 over 18 x squared minus 1 over 18x plus 20 over 18, which is 10 over 9. Don't worry about the fractions there. Leave them as fractions. It's fine. Don't go rushing to make them decimals or weird stuff. Yeah, that's it. So be familiar about what to do with what you're given. I mean, obviously, if you're given the vertex, use vertex form. If you're given the zeros, I mean, there is this. This is actually intercept form of a quadratic. That's a p and a q value. But even if you don't know it, I mean, you can easily get the factors and the zeros from that. Okay, next page. Number 6 is a tricky one. So actually, what I'm going to do is I'm going to give myself more space here. So, yep. I'm going to mask this. And then just move it down the page. Whoops. So maybe that'd be a good amount of space. Okay. Right. So let's go through this one, number 6. And 7's also a tricky one. Oh boy. Number 8's not bad though. Okay. Here we go. This is tricky. So we know it's a cubic, so there are going to be 3 zeros. So the factors here are going to be we're going to have, if the 0 is at 3, we're going to have x minus 3. And then here we have 2 minus root 5 is a 0. So that means that the factor is going to be x minus 2 minus root 5. Make sense? But 2 minus root 5 is, if this is a 0, its conjugate is also going to be a 0. So that's going to be x minus 2 plus root 5. Do note that it's not the conjugate of, when we think of conjugates, we think of the sign switching. It's these signs here that are switching within the actual 0 itself, not next to the x. So understand that. Now this looks like it's going to be crazy to FOIL, but the hint says use the sum and product rule. The sum and product rule is actually really nice. So if we ignore this x minus 3 for a second, the sum and product rule is more or less this. It's if I have x minus 2 and x plus 6, right? I'm going to get x squared, plus 6x minus 2x, so that's plus 4x minus 12. The sum and product rule is this. If I look at these two numbers, negative 2 and 6, what's the sum? What's negative 2 plus 6? 4. What's negative 2 times 6? Negative 12. Boom. So if I look at this, I know this is going to give me a trinomial, a quadratic trinomial. So it's x squared minus, because it's a minus and a minus, the sum of these two numbers. Well, what's 2 minus root 5 plus 2 plus root 5? Minus root 5 plus root 5 is 0. So I basically get 2 plus 2, which is 4, and that's the coefficient for x. Now what if I multiply them? Well, if I multiply them, and I can do that over here, this is the product. I get 2 minus root 5 times 2 plus root 5. I'm multiplying conjugates, so I'm going to get a difference of 2 squares. 2 squared is 4, minus root 5 squared is 5, so that's minus 1. So that's it. Suddenly everything's rational, and I just have to distribute these guys. So when I do that, I'm going to get y is equal to x to the third minus 4x squared minus x minus 3x squared plus 12x plus 3. So I get y is equal to x to the third minus 7x squared plus 11x plus 3. And that's it. Whoops. So understand the sum and product rule, know how to use that, know how to work that, and it makes this process easier. Could you have foiled this? Absolutely. But look at how much easier this was. And we're going to do that same process again. Oh boy. We're going to do that same process again with number 7. So here we go. Find the equation of a polynomial with zeros of -4, 7 plus 2i, and passing through this point. So this means we're going to have a coefficient this time around. So actually, why don't I again copy this? So maybe I'll do this number 8 on the next page. So I'll give myself some more space here. And so we know it's going to be y is equal to, we're going to have a leading coefficient of a. The 0 is -4, so that means that this factor is going to be x plus 4. And again, we know that we're going to have x minus 7 plus 2i. So that means that we're going to have its conjugate, x minus 7 minus 2i. Here we use the sum and product rule. We're going to ignore this x minus 4 for just a second. And again, x times x is going to give us x squared. If we're minusing and minusing, it's going to be minus. Here, if we have the 7s, we're going to do 7 plus 7 is 14. 2i minus, or 2i plus -2i is 0. So minus the 14x. And then if we multiply these, it's going to be 7 times 7, which is 49. 2i minus 2i, it's -4i squared. So that's plus 4. So 49 plus 4 is 53. And then we have the x plus 4 with our a in front, and we're going to distribute this through. So actually what we can do is this. We say y is equal to a, and distribute all this. So we're going to have x to the third minus 14x squared plus 53x plus 4x squared minus 48 times 4, sorry, not 48 times 4, 14 times 4, which is minus 56x, and then plus 53 times 4, 53 times 4, which is going to be 212. So if I just simplify this, y is equal to a times x cubed minus 10x squared minus 3x plus 212. And I know that it goes through the point 2, 1, so I get 2 is equal to a times 1 minus 10 minus 3 plus 212. So 1 minus 10 minus 3 plus 212 is going to be 200. Divide both sides, so I get that a is equal to 1 over 100. Plug it back in, so I get y is equal to 1 over 100. I can distribute this all in. Ugh, my x. 1 over 100, x to the third, minus 10 over 100 is 10x squared, minus 3 over 100x, plus 212 over 100. There's some common factors there. We can say that's 53 over 25 after reducing the fraction. And that's going to be our answer. So again, really this is knowing the sum and product rule. Then once you get through that, it's just simplifying from there. So set it up, sum and product, and combine. All right, and finally, let's, on this next page, whoops, let's just do number 8. Do this on the last page here. Okay, so first off, we want to do when we have a problem like this is we want to factor. So let's do that. So f of x, if we factor the greatest common factor in the numerator, well, that's actually going to be x times x squared minus 4, but that's going to give us x times x plus 2, x minus 2. And down here we're going to have x plus 2, x plus 1. We have a common factor of x plus 2, so we reduce this to x times x minus 2 over x plus 1. Remember, wholes are where we have this, what we call removable discontinuity. So the whole, so for A, the whole is going to be where x plus 2 equals 0. So that's x equals negative 2. For the x-intercepts, that is where the function is equal to 0. If the denominator is equal to 0, then it's undefined. So we're going to put the numerator, specifically the numerator that's left. Here we're going to have 2. This is x is 0 and x is positive 2. So we're going to have 0, 0, and we're also going to have 2, 0. Then we're going to have the y-intercept. The y-intercept is where x is 0. So, I mean, if you actually, if you look at this, where this is 0, we have 0 over 1. And also, if you look at the x-intercept, it crosses the y-axis at the origin. So that's 0, 0. The vertical asymptote, really simply, it's what's left in the denominator that we did not cancel out. So here, x plus 1 equals 0. So x equals negative 1. It's going to give us a lovely vertical asymptote there. And the horizontal asymptote, we have to look at our rules. So here, we see that the degree in the numerator is greater than the degree in the denominator. So that means that there is no horizontal asymptote. So for this, know your rules. Focus on factoring. And there are a bunch of problems like this that we went over in class and in the textbook. So use those. And good luck studying.